Black holes are the universe's most enigmatic phenomena, bending space, time, and our understanding of physics itself. These cosmic behemoths form from collapsed stars or cosmic collisions, swallow light and matter with such ferocity that they challenge the very laws governing reality. In 2025, with breakthroughs like the Event Horizon telescopes, stunning images, and gravitational wave detections, we've learned more about black holes than ever. Yet for every answer, new questions emerge, leaving scientists and the curious among us grappling with mysteries that defy explanation. What lies inside a black hole? Can they connect to other universes? And why do they keep surprising us? Let's dive into the abyss and explore what we still don't know about black holes, with questions to spark your curiosity along the way. What are black holes really? At their core, black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape. They form when massive stars, at least 8 times the sun's mass, exhaust their fuel, collapse under their own gravity, and compress into an infinitely dense point called a singularity, surrounded by an event horizon, the point of no return. Supermassive black holes, millions or billions of times the sun's mass, lurk at the centers of galaxies, like Sagittarius A in our Milky Way. Primordial black holes, hypothetical relics from the Big Bang, might be as small as an atom yet weigh as much as a mountain. But what are they beyond these descriptions? Are singularities real, or are they a sign our physics breaks down? The math of general relativity predicts singularities, but quantum mechanics suggests infinities don't exist in nature. This clash leaves us wondering, is a singularity a physical object or just a placeholder for our ignorance? Some theories, like loop quantum gravity, propose a quantum bounce inside black holes, avoiding singularities altogether. Others suggest exotic structures like Planck stars. Without direct observations, impossible past the event horizon, we're left guessing. What do you think lies at a black hole's heart? The information paradox. Where does it all go? One of the biggest puzzles is the black hole information paradox. Quantum mechanics insists that information, say, the quantum state of a particle, can never be destroyed. Yet when matter falls into a black hole, it seems to vanish beyond the event horizon. Stephen Hawking's 1974 discovery of Hawking radiation added a twist. Black holes slowly evaporate by emitting particles, losing mass over billions or trillions of years. But does this radiation carry the lost information, or is it truly gone? Hawking initially argued information is destroyed, challenging quantum mechanics. Modern theories like the holographic principle suggest information is encoded on the event horizon's surface, preserved in a 2D hologram. Recent breakthroughs, like the 2020 calculations by physicists at MIT and Caltech, propose that quantum entanglement in Hawking radiation could resolve the paradox. Yet we lack experimental proof. If information isn't lost, how is it stored and retrieved? Could black holes be cosmic hard drives, preserving the history of everything they consume? Your guess is as good as the physicist's. What's inside the event horizon? The event horizon is the ultimate veil, hiding a black hole's interior from the universe. General relativity predicts a singularity where density is infinite and space-time curves beyond comprehension. But quantum mechanics and string theory suggest alternatives. Some propose firewalls, intense energy barriers just inside the event horizon that incinerate anything crossing it. Others, like the fuzzball model in string theory, imagine black holes as tangled balls of quantum strings, not singularities at all. Without a way to probe inside, we're stuck theorizing. Missions like the proposed Black Hole Explorer, BAEX, set for the 2030s, aim to image event horizons in greater detail. But they won't pierce the veil. Could we ever send a probe inside and get data back? Or are black holes destined to keep their secrets? Imagine you could peek inside. What would you expect to see? Do black holes lead to other universes? Science fiction loves the idea of black holes as portals to other dimensions or universes. Surprisingly, physics doesn't entirely rule this out. The mathematics of rotating Kerr black holes suggests the possibility of wormholes, tunnels through space-time connecting distant regions or even separate universes. Einstein-Rosen bridges, theoretical wormholes, arise in solutions to general relativity, but they're unstable and likely collapse instantly. Some physicists, like Juan Maldacena, propose that black holes could be entangled with other regions of spacetime, creating cosmic shortcuts. But there's a catch. Wormholes, if they exist, are likely non-traversable, meaning nothing could survive the journey. Still, the idea persists. Could black holes be gateways to parallel realities? If you could travel through one, where would you hope it leads? Why do black holes spin and merge? Most black holes spin, some at nearly the speed of light, dragging space-time around them in a phenomenon called frame dragging. This spin affects how they accrete matter and emit jets of energy, like those seen in quasars. But why do some spin faster than others? And how do supermassive black holes, like the 4.3 million solar mass Sagittarius A, grow so large? Mergers are part of the answer. The LIGO-Virgo collaboration has detected over 90 black hole mergers since 2015, revealing how stellar mass black holes combine to form larger ones. Yet the origins of supermassive black holes are murky. Did they grow from stellar remnants, or were they seeded by primordial black holes in the early universe? The James Webb Space Telescope's 2023 discovery of massive black holes in young galaxies suggests rapid growth. But the mechanism, accretion, mergers, or something else, remains unclear. How do these cosmic giants form so quickly? And what sets their spin rates? Are primordial black holes dark matter? Primordial black holes, theorized to have formed in the Big Bang's chaotic aftermath, could range from microscopic to mountain-sized. Some scientists hypothesize they account for dark matter, the invisible 27% of the universe's mass that influences gravity but emits no light. If true, primordial black holes could explain galaxy formation and gravitational lensing anomalies. However, searches by the LIGO and Subaru's HyperSuprime have found no conclusive evidence. Constraints suggest primordial black holes, if they exist, make up only a fraction of dark matter. Are they out there lurking undetected? Or is dark matter something entirely different, like exotic particles? If primordial black holes are real, what role did they play in the universe's infancy? Can we harness black holes? Black holes are theoretical powerhouses. A rotating black hole's ergosphere could, in principle, extract energy via the Penrose process, where particles gain energy by skimming the spinning space-time. Advanced civilizations might build black hole power plants, as proposed by physicist Roger Penrose. Hawking radiation, though minuscule for stellar mass black holes, could also be a future energy source for microscopic ones. But practicality is a problem. The energy output is tiny, and manipulating black holes is beyond our technology. Still, the concept raises questions. Could black holes power future societies? Or are they too dangerous to tame? Imagine a civilization harnessing a black hole. What would that look like? The human quest for answers. In 2025, we're closer to understanding black holes than ever. The Event Horizon Telescope's 2019 and 2022 images of M87 and Sagittarius A gave us our first glimpses of their shadows. LIGO's gravitational wave detections map their mergers. Yet each discovery raises more questions. Future missions like the European Space Agency's LISA 2037 launch will probe supermassive black hole mergers, while quantum computers might simulate their interiors. Still, the unknown looms large. Black holes challenge our theories, from general relativity to quantum mechanics. They force us to question reality itself. Are they gateways, destroyers, or cosmic archives? What new mysteries will they unveil? Share your thoughts below and like and subscribe for more content on the universe's greatest enigmas.